think the one thing that was benefit about coming to school here, you know, with it being a 2-year program, you can always further your education. And, you know, the one thing you can't take away is your education. So once I left here and I was working full-time, I decided to go back to school. And while I was going back to school, I could kind of see what needed to be touched on more in my education, which was the sustainability movement in the construction industry. So I went back and got my LEED AP, which has helped tremendously in my career by kind of knowing and understanding how sustainable building goes and development goes further. So on the education side, you know, coming here with the 2-year program is probably the highlight of, you know, when leaving is going to get that LEED AP accreditation. The success that I've had in my career is completely all to thank towards the WCCT. Having the technical background, being able to have a hands-on approach, touching the material, being with the material, kind of more of a hands-on approach to it, to actually when you go to talk about it in a meeting or on site, you actually know what you're talking about. And that's the best part about this program, is that it's a hands-on program. So, I mean, you're making cylinders, you're making test beams, you're doing everything that you would be doing in the work life in a construction field area. And from there, whether you're in the field working, doing those tests, or whether you're in a boardroom, you're still applying that knowledge. Looking back at it, I mean, there's so many things that we touched on while we were here in class that, you know, going out and applying that, I mean, every job is different. And whether you go on the admixture side, whether you go on the cement side, it really depends. So I guess further education, maybe it's kind of outside of here. Besides, you know, like sustainability, business, anything like that that can grow you. Now construction has completely changed. Your typical construction site now is completely maintained. Everything is being reused, recycled, and concrete ties pretty well in with that, because it is a raw, natural material, and it's a huge movement. It's not going away. Right. Just like they say with every, you know, like every type of material, it kind of comes and it goes. Sustainability is not going to go away. It's what's right, and it's how we build nowadays. The development of, after leaving ACC with my career, was I graduated in '04, and from there I moved to Indiana and took a job with the Indiana Ready Mix Concrete Association as a Southern Promotion Director. I covered all promotion, sales, certification classes, anything state work, bid work, anything that kind of came through the state with concrete, I dealt with, along with NRMCA trading classes. From there, I kind of moved up and took over the entire state for covering certification, got involved with ACI, and started sitting on their board and doing their certification classes, and kind of started to go towards teaching at the universities and doing concrete one-on-one with them. It was actually kind of shocking, only being in Indiana, how many, let's say, ready-mix producers never heard of our school, and it's only 12 hours away from my home, or I guess where I live currently. I think there's just a small gap between the WCCT and then also promoting the program, whether it be to state associations, like where I work, the Indiana Ready Mix Concrete Association, or MCA. Every state has a concrete association. Every year they have a concrete convention. You know, being there, being in front of those higher offers. You can't ask whether it's an internship, whether it's a full-time position. Coming out of here with all your certifications is a plus. An employer doesn't want to have to pay for that. And coming out of here, you already have them. Part about my job, which makes it really interesting, is that it's a public job, it's a political job. You're in front of a lot of people, you're doing a lot of public speaking. So being, at the World Center for Concrete Technology, learning here and then applying it at different conferences, whether it be state conferences, whether it be World of Concrete, whether it be Con Expo. And you can talk about all different types of material, whether it be pervious concrete. There's a lot of different materials that you touch on being here at the WCCT that you can apply in any presentation, and that helped me out tremendously. The state associations have a great tie into the entire industry, the entire concrete construction industry, whether it be cement producers, whether it be ready mix, whether it be admixtures, you name it. So I think there's a lot to be captured there, and it's a great audience to have because those are the people that will be hiring for these positions.
Welcome to Harris Hall and the World Center for Concrete Technology. Come see why this is a very special and unusual facility. It's not only a premier center for training, educational research, and testing for the concrete products and concrete industries, it is also a demonstration of the architectural variations that concrete and concrete products offer. Built on a foundation of partnering, the World Center concept began as a Besser Company training program in 1954. The concept and facilities have grown over the years to include Alpena Community College. In 1966, the Besser Technical Center was constructed on the college campus, and the 2-year Applied Science and Concrete Technology degree program was established. The concept and facilities took another major leap forward with the completion of Harris Hall in August 2000, formalizing the World Center for Concrete Technology. This advancement would not have been possible without the partnering of the State of Michigan, U.S. Departments of Commerce and Agriculture, and the concrete products and concrete industry companies who have invested a combined total of $8 million. The mission statement of the center is ambitious: to provide leadership, advancement, and mastery of concrete technology through education, training, research, testing, information management, and communications. This is accomplished by securing shared participation, cooperation, assistance, and support of all those interested in concrete technology worldwide. The WCCT is self-sustaining, operating on funds provided by its training programs, research projects, testing services, and donations from interested companies and individuals. The backbone of the WCCT's support is an advisory group called the Partners Council. Each member of the council has provided significant financial contributions and is dedicated to providing continued support through technical assistance, participation in ongoing training programs, and by utilizing the facility's resources for research projects and company meetings. What distinguishes the WCCT from other training centers is the hands-on nature of its training and educational programs. The WCCT provides real-world skills and knowledge to help students quickly become major contributors to their employer's bottom line. How is this accomplished? Through the 2-year Concrete Technology Program, through block makers and pipe makers workshops, through industry training courses, and by offering high-quality research and conference facilities, from the materials and project labs, to the production lab, to the classrooms. Each area of the WCCT is state-of-the-art. When people talk about the hands-on, real-world experience they receive at the WCCT, they're not using those words lightly. Take a look and see how the center brings the real world into the classroom, and the classroom into the real world. From the batch plant, to the laser screed, to the full-size, state-of-the-art concrete products plant, the teaching emphasis is on materials, operating from the comprehensive perspective that to understand this industry, one must first understand the materials used. Whether students in the 2-year program or industry members visiting for additional training, what is learned here translates directly back to the job. Just ask a few people who have taken courses at the WCCT.
Throughout my freshman year and sophomore year, I was amazed. I just, this is, we got a huge block plant, a huge lab, just anything you need, we've got, and if we don't have it, we've got it within a week or so. We've got great access to all products. It's just it's a well-known course around the U.S.
I did some research before I came up here, and I found a couple other schools with concrete programs, but their programs are mostly business and a couple of classes for concrete, and this program here is the best by far. I've already learned so much about it, and when I got up here, I was amazed with all the technology and new equipment they have for us to use, even in first-year students.
It's hard to find a program that is so in-depth, covering what particular concrete construction or just construction-related companies are looking for. So by having the program be able to be molded to a certain person or individual requirements is very, very good as a company owner wanting to find someone for that position without having to spend a lot of time trying to explain what some of the basic tests or requirements of our industry are.
I came to the Dynapack class before we even bought a block plant. And then after I had ran the block plant for a year, I came back to the Dynapack just because there was a lot of stuff now that I've seen that I didn't know that they showed me. And then we moved on to electricals and vibrators and product handling now, and everything's a really great class.
The reason my employer signed me up for the Block Makers Workshop at the World Center for Concrete Technology is to increase our output, increase our efficiency, and to put somebody in the field to help train the other employees at the plant. After I had the classes at the Block Makers Workshop, I went back with a higher confidence and a great higher skill level to be able to operate and run the machines.
The WCCT is always seeking ways to expand its services to serve an even broader range of the concrete industry. Listening to industry needs, it added several courses to the traditional class lineup, including a 2-day seminar on Allen-Bradley control processors, a 1-day program for architects on concrete product manufacturing and architectural concrete masonry, workshops geared toward management training, and a 2-college credit week-long course on concrete pipe materials. And the WCCT is still listening.
In my 25 years with Besser Company, it's been a real privilege to work in a facility like the World Center for Concrete Technology. As Director of Research and Training for Besser Company, it's our job to try and educate the individuals that purchase Besser equipment. The facilities that we have here are just excellent tools for that. We've got the education, the training, and of course the research that goes with that.
And our focus is building the industry and developing concrete masonry technology so that we satisfy the future needs of the industry. A center like this is certainly key to that growth.
Research has been an important part of the World Center's evolution from the beginning. The WCCT offers confidential research and testing services on a broad range of topics for the concrete and concrete products industries. Past research topics have included work on admixtures, pigments, waste ash of many types, slags, ground glass, plastic, rubber, and solid waste, just to name a few. All research and testing is supervised by ACI and NCMA certified technicians. The World Center for Concrete Technology is advancing the interest of the concrete and concrete products industries through workforce training, confidential research projects, certified testing, and academic degree programs.
The World Center for Concrete Technology really gives businesses and industry an opportunity to have a resource available to them that's probably nowhere else in the world.
But this can only happen with the help of donors and partners. Although the World Center is building on a tradition begun almost 50 years ago, the work has really just begun. To maintain its growth, the WCCT needs continued support. To find out how your company can participate or assist in the development of new programs at the WCCT, or how to contribute to an ongoing program, please contact the World Center today.
With the concrete technology program here at Alpena Community College, the workload was a demanding workload, but the program itself is tailored to hands-on experiences and real-world applications that you're going to see every day in the field. So the preparation this program gives you is great. It's a great program, one of the best technical programs that I know of probably in the country, that prepares you for when you leave this program. You're going to be ready to do all the things that you've learned, and you're going to know where you sit.
Welcome to the World Center for Concrete Technology. My name is Eric Krebs. I'm one of the co-directors here at the center, and I'm pleased to host this video on concrete masonry production. As you can see from the building behind me, the World Center for Concrete Technology is made out of masonry. Masonry has a lot of attributes. One is that it's very pleasing to the eye. Also, structural integrity would be another commodity. It's the intent of this video to show you what goes into making concrete masonry, or CMUs. Those would be materials such as sand, stone, cement, and water. In the application behind me, there's also pigment or color in this process. We're going to show the mixing, the proportioning, how we mix that recipe together, how it goes through a concrete products machine. Then we'll convey it to a curing chamber, coming out of the curing chamber in X amount of time. We'll go down an unloading line, and then it will be going through the cubing system that will package the product and put them in the yard for storage. Most block companies have many different sources of aggregates. Those sources of aggregates come into a yard typically, and they're either dumped in piles, like this particular pile of sand, or they're dumped underground with conveyors going up into holding hoppers or holding bins. As we talked earlier, our particular mix design is going to be sand, stone, cement, and water. So what I'm going to do is take a sample of our 2NS, which is 2 natural sand. 2NS, it's a MDOT designation. Now I'm just going to take a sample of it. But before I do that, I want you to understand that there are sampling methods, and I'm not conforming to those particular methods. So what I'm going to do is just take some sand, and we'll take it back into the laboratory, and we will do a sieve analysis on it. So this is the typical sand that I will use. This is what we call our stone. Some have other designations, number 8, number 9, maybe a P stone, but in our case we call this 29A, another MDOT designation. So I'll take a sample of that also. Once I've got my 2 samples, sand and stone, I can go back to the laboratory and do what we call a sieve analysis on these 2 aggregates. Welcome back to the lab at the World Center for Concrete Technology. We're still talking about the ingredients that go in a concrete masonry unit. This is the sample of sand that we took from the pile a few moments ago. I have to do a few more things to this particular sample of sand to get down to a mix design for that concrete masonry unit. So the first thing I've done is I've taken that sand and I've dried it out in an oven. You may see that it looks a little different, but it just has the moisture removed. I've also got my 2NS sand, and I've also got my 29A. That's my stone. The other ingredient, as we've talked about, was Portland cement. This is a type 1-2 Portland cement. The last ingredient, water. In what proportions is our next quandary. As these are proportioned and mixed together, it's our intent to make a concrete masonry unit. However, this is a miniature block, and does not conform to the standard block size of an 8-inch by 8-inch by 16-inch concrete masonry unit. So next in the process is taking this sand and getting it down to a sample size that I can use for a sieve analysis test. And by the way, all these tests are done in accordance to ASTM specifications. I've taken a few liberties that a normal lab would not. So what I've done now, the next step would be to put this aggregate, the sand, into a riffle sampler and break down the material to a sample size that I can use. I've done that ahead of time. So this is what I've got for a sample now of the sand, the dry sand. So now I would take my dry sand, which should be about 500 gram sample, but I want to make sure of this weight and exactly how much of this material I have. So I'm going to take it over to a scale and make sure I get that weight. And yes, I have about 500 grams. This happens to be 488. But I use that total sample, and now what I'm going to do is break that sample down into each individual particle sizes within that total sample. And I do that through a sieve analysis. So I'll start that process. In the sieve analysis, we have screens. These screens have holes in them, and those holes represent the size of a given particle that will pass through them. This happens to be a number 4 screen. What does the 4 mean? 4 means that there are 4 openings per linear inch. The next size down would be a number 8 screen, and of course, correspondingly, 8 openings per linear inch. As I go down finer and finer, 16 openings per linear inch. So I think you can see by this that as material passes by these particular screens, it's going to retain a certain amount of material on each screen, and that is what we're going to call the percent retained. So to do that, I take that 488 gram sample that I weighed out, and I'm going to pour this into the top screen. Once I've done that, I'm going to put the top on, and then again, according to specifications of ASTM, I'm going to shake this sieve for approximately 4 to 6 minutes. That's the next process. I'm going to put the screens, the nest of screens, into the shaker, put the top down, and set my timer for approximately 4 to 6 minutes. It depends on how many sieves you have is the amount of time that I'm going to shake for. And I'm going to let that shake for that allotted 4 to 6 minutes. At that point, I'm going to take it back and find out how much material is on each individual sieve. So now I take the top off, and I would see the particle sizes that are on this particular pan and find out how much each particle size weighs. That way I'm breaking the particle sizes down, and I'll relate to that in a moment. So as I look over at the particle sizes that came out of these sieves, I have the same numbers: 4, 8, 16, 30, 50, 100, and pan. You'll note that the size of the particles goes down as the number gets higher. So this was all that was actually retained on that number 4. This was the only retained on the number 8, and so forth till I get down to my pan or my very fine dust. Why would I do this? Well, that's going to tell me, once I do the calculations, I can put this in a computer and tell the fineness or the texture that this block is going to have. Now remember, this is only processed with just the sand. I'm going to do the same process with the stone. At that point, I'll graph it, put it on a graph, and then that will tell me if I need 20% of the stone, 80% of the sand, vice versa. Those proportions will tell me what to do with that particular block. Of course, then I'm going to add the cement, and I'm also going to add the water. To put it into proportions for you, it's going to be about 1 part cement for every 10 parts of this combined aggregate. And of course, we're going to have that water. Once that is mixed up, I can start putting it through the block machine and make our concrete block. We're going to head to the block plant now and show you that process of weighing up the material, mixing these materials, but on a much broader scale. One of the first things we need to have is a continual supply of those materials we have just talked about. The white silo is where the cement is being stored. This particular silo holds 50 to 100 tons of cement. Next, we're showing how to transport the aggregates from the piles in the yard to the storage bins inside the facility. We are using dump hoppers and a conveyor system that conveys those materials to individual bins inside the building. When the materials enter the building, they are shuttled to individual bins that hold the same type of material. These bins each hold 50 tons of material. So in theory, I can store 300 tons of 6 different types of materials inside this building. Once we've gotten the proportions of the aggregates to be used in the final mix design, these clam gates drop that predetermined amount of material onto weigh belts. From there, the sand and stone are weighed. The conveyors transport the aggregates toward the mixer. This particular mixer has a capacity of 6,000 pounds, which is considered one batch. Once the aggregates are in the mixer, the cement is added along with the correct amount of water. This is all an automatic process. Typically, this material only requires about 6% total moisture. All the materials are mixed from 4 to 6 minutes, and then the mixer gate opens, transferring the mixed material to a holding hopper behind the block machine. From there, the material enters a small hopper directly above the block machine. In this short production run that you're seeing, we are making CMUs that are 8 inches by 8 inches by 16 inches, 3 at a time. So approximately every 7 to 8 seconds, we produce 3 units. Notice that they are being produced on a steel pallet. This is a production rate of approximately 21 blocks per minute, or 1,260 blocks per hour. The moisture percent, the mix design, and the configuration of the blocks being produced determines these cycle rates. Next, the blocks are conveyed on the front delivery conveyor toward a stacker. Notice that the blocks are being checked for the correct height at this stage, and then the tops are being brushed off to eliminate any imperfections. The blocks are first stacked in a loader 9 high, and then a spade moves from the loader stacker into the rack. These racks can carry 324 blocks or 108 pallets. Now the racks are being shifted out of the way, awaiting pickup from a crawler that goes underneath the rack, picks it up, and transports it back to the car. Once the rack is back on the car, it is transferred to the kilns for curing. This curing can take as much as 24 hours at approximately 120 degrees Fahrenheit. Once the green block rack is deposited, the car then picks up a cured rack and brings it back to the unloading station. The cured block are then conveyed down an unloading line. As they go into a depalleter, which pushes them off the steel pallet, the empty pallet is then recycled to the back of the machine for reuse. Then the blocks are conveyed toward the cuber. This cuber packages the block to conform to the customer's request. The series of turntables automatically accomplishes this task. Then each tier is stacked on top of the other using a wooden pallet. Once this is accomplished, a full cube of 90 blocks is pushed out the door and awaits pickup by a forklift. This operator either stores the cubes in the yard or places them right on the truck for transportation to the job site. Well, you just had a tour of the World Center for Concrete and its block making facility. We started out with sand, stone, cement, and water, and now we've got a product that'll pass all the specifications and standards in our industry. It was my pleasure to host this video at the World Center for Concrete Technology. I'd also like you to remember that we are a research facility to helping masonry and masonry aspects around the world. We also train block makers from all over the world. We are a lab for Northeast Michigan for all types of concrete, and we also house a 2-year associate's degree in applied science for concrete technology. And if you've got any questions, please don't hesitate to call us at the World Center for Concrete Technology here in Alpena, Michigan. Please visit our website, and remember, if you're going to build it to last, and build it out of concrete.
Absorption. Supplies needed: absorption tank, tank heater, block basket used to attain the immersed weight of block, sponge, 3/8 inch mesh tray, and an oven. Next, the 3 units used in the absorption test should be placed in the tank, totally submerged in water for a 24-hour period. After the 24 hours have passed, each block must be weighed, recording the immersed weight before removing the block to attain the SSD weight. Prior to recording the SSD weight, the block must be removed from the water, sponged off, and allowed to drain for a period of 1 minute plus or minus 5 seconds. Place the unit on the 3/8 mesh tray while it is wiped down with a damp sponge or cloth. Once the SSD weight has been recorded, the unit must be placed in an oven. Subsequent to saturation, dry all specimens in a ventilated oven at 212 to 239 degrees Fahrenheit for not less than 24 hours and until 2 successive weighings at intervals of 2 hours show an increment loss not greater than 0.2%. Record weight of dried specimen as oven dry weight. Formulas used along with the data collected from these blocks will help determine if the blocks meet the required specifications. ASTM C1552-03A. Standard practice for capping concrete masonry units, related units, and masonry prisms for compression testing. Supplies needed: capping plate, gypsum plaster, spoon, mixing bowl, rubber mallet, application tools, water, oil, and a brush. When capping concrete masonry units, the plate must be plugged in and given sufficient time to warm up. At this point, it's important to lightly cover the plate with a film of oil or apply a coat of TFE fluorocarbon coating. The next step is to mix the gypsum plaster with water to a water gypsum cement ratio of 0.26 to 0.30. Using the mixing spoon and bowl, the mixture must be thoroughly stirred. Now the mixture must be poured onto the plate. Using the application tool, the mix must be spread evenly and in a manner so the thickness of the cap on the block will not exceed 1/8 inch in thickness. After the mix is spread, the blocks can now be placed on the plate, and as the compound hardens, it's important to clean up the excess compound around the blocks. Once sufficient time has elapsed and the compound has hardened, the blocks must be separated from the plate. Prior to trying to move the block, use the rubber mallet to jar the capping plate. After repeatedly striking the surface of the plate, softly tap each block, looking for signs that it's broke loose. Once the blocks have been removed, the table should be cleaned and re-oiled before mixing up another batch of gypsum plaster in order to cap the opposite side of the blocks being capped. It should be noted that cardboard and styrofoam can be used for testing of compressive strength when the producer is looking for a quick method to obtain strength results. Disclaimer: this segment on capping is meant to merely provide you with a visual understanding of the process, and the viewer should always review the ASTM standard when actually performing the test to be sure it is conducted properly. Clay test. The clay test is a quick and simple method to check the percentage of clay in fine aggregate. All you need for this test is a 1-quart mason jar and lid. To start the test, place approximately 2 inches of fine aggregate in the mason jar. Next, add water until the jar is 3/4 of the way full. Secure the lid and shake it vigorously and leave it sit for 1 hour. After an hour, measure the clay layer which settles on top. If the clay layer is over an 1/8 inch in thickness, this demonstrates the percentage of clay in the material being tested is over 3%. If this is the case, the material being tested will need to be washed before being used. It should be noted that this test only applies to fine aggregates. There is also a test that can be conducted in accordance with ASTM C117, but it is more time consuming. ASTM C140-06. Standard test methods for sampling and testing concrete masonry units and related units. Compression. Supplies needed. Compression machine. Disclaimer. It should be noted that anyone performing any testing pertaining to ASTM C140-06 should read it very closely. This video presentation is merely a visual example of these tests. Viewers also need to be aware of the importance of Section 6 compressive strength and A13 to be sure the machine being used to test the company's concrete masonry units is certified and passes the specifications laid out pertaining to the upper and lower platens. Prior to breaking a concrete masonry unit, be sure that the top platen and bottom platen are free of any debris. Use a brush and hand to be sure this is the case. Next, you must place the CMU so it's centered and set inside the platens. When the machine is ready, position the rapid advance handle until the load pounds are approximately 50% of what it is estimated the CMU will break at. At this point, the handle is repositioned to the metered advance position. It should be noted that this test must be completed in the time frame of 1 to 2 minutes to pass the standard. It is also recognized that there may be some adjustments made to the rate the load is applied, as well as what load the handle is repositioned from rapid advance to the metered advance to achieve the desired failure within the specified time. After the CMU has failed, be sure and record the load pounds at which it broke. Reset the machine for the next CMU. Different mix designs can affect the way a CMU breaks. A perfect break is when the unit breaks in such a way the sides shear, and on the end of the unit it looks as if it's cracked in an X pattern. Normally, the compression machine will recognize a unit has failed prior to any noticeable cracking. So while the failure could be in the desired X fracture, it isn't visually apparent. ASTM C117-04 Standard test method for materials finer than number 200 sieve in mineral aggregates by washing. Loss by wash. Supplies needed: a 200 sieve, scale, hot plate, oven, or microwave. Additionally, a small putty knife, spatula, or spoon will be needed for redistribution of material from the sieve to a pan. The loss by wash test can be performed during the process of preparing a sample for a sieve analysis. Important: be sure to record the dry weight of the material before proceeding. Over the course of the preparation of a sample for a sieve analysis, a wet weight and a dry weight have been determined, allowing the moisture content to be calculated. The sample is now poured into a 200 sieve and rinsed completely with water. The sample must be thoroughly rinsed until the water pouring through the sieve is clear in color. After completely washing the material, be very conscious of the distribution of material from the 200 sieve to the pan. Be sure to wash the material into one area in the sieve before removing it to the pan. Continually wash all the material from the tools back into the sieve. Be careful not to lose any material. This can affect the end result. Repeat this process until all the material has been removed from the sieve and placed into the pan. Once again, the material must be dried to a constant mass at a temperature of 230 degrees plus or minus 9 degrees Fahrenheit. Disclaimer: it should be noted, unless the loss by wash test is being run for more than a quick verification, any testing pertaining to this procedure, the ASTM standard, should be read closely. ASTM C40-04 Standard test method for organic impurities in fine aggregates for concrete. The organic impurity test is relatively simple. The only supplies needed are 2 8 to 16 ounce graduated colorless glass bottles, a scale, and a glass color standard. To perform this test, you'll also need sodium hydroxide. To complete the test, we will be using the glass color standard to determine our results. Proper mixing requirements are 3 parts by mass of reagent grade sodium hydroxide in 97 parts water. First, weigh out 4.5 ounces of fine aggregate and place it in the graduated glass bottle. Next, fill the second glass container to approximately 200 milliliters or 7 ounces with water. Using the scale, weigh out 6 grams of the sodium hydroxide. Add the sodium hydroxide to the water, stirring it well. Pour the mixture into the bottle with the fine aggregate until the level reached is 200 milliliters. Place the cap, tighten it, and shake it vigorously. Allow it to stand for 24 hours. At the end of the 24-hour period, use the color glass standard to define the results to the standard. When a sample subject to this procedure produces a color darker than the standard color, or organic plate number 3, Gardner color standard 11, the fine aggregate under the test shall be considered to possibly contain injurious organic impurities. It is advisable to perform further tests before approving the fine aggregate for use in concrete. ASTM C702-98, reapproved 2003. Standard practice for reducing samples of aggregates to testing size. Method B, quartering. Supplies, a straight edge shovel and a broom or brush. Procedure, place the aggregate sample on a clean, flat, hard surface and mix it thoroughly by turning the entire sample over 3 times. With the last turning, shovel the entire sample into a conical pile by depositing each shovelful on top of the preceding one. Carefully flatten the pile to a uniform thickness and diameter using the shovel. The diameter should be 4 to 8 times the thickness. Divide the flattened sample into 4 equal sections and remove 2 of the opposite sections. Repeat this process until the sample has been reduced to the desired size, approximately 454 grams or 1 pound. ASTM C702-98. Standard practice for reducing samples of aggregate to testing size. Method A. It should be noted, when sampling aggregates, one should start the process in accordance with the ASTM D75, practice for sampling aggregates. Your initial sample should be in a saturated surface dry condition before attempting to reduce it. At this point, the sample should be reduced so it won't weigh less than 5,000 grams dry. When reducing the initial sample down to the 5,000 gram dry weight, arrange the chute openings so they are 1.5 inches or more in width. When using the ripple sampler for the final reduction, the sample should be reduced down to approximately 1 pound or 454 grams. A Upon starting to reduce the fine aggregate sample down to approximately 1 pound, the chute openings should be reduced to between 1/2 to 3/4 inch openings. Procedure: dump the sample into the feed chute. Be sure to distribute it from edge to edge so when it's introduced to the chutes, the material will flow in equal amounts through all of the chutes. Introduce the material so it will flow freely through the chutes and into the receptacles below. Reintroduce the material from one of the receptacles as many times as necessary to reduce the sample down to the required size specified for the intended test. ASTM C136-06 Standard Test Method for Sieve Analysis of Fine and Coarse Aggregates. Sieve Shaking. Supplies needed to test fine aggregate: 3/8, 4, 8, 16, 30, 50, and 100 sieves. Finally, a pan, lid, sieve shaker, scale, and specialty brushes will be needed. The sieves should be stacked in order, placing the largest sieve being a 3/8 on top, followed by the 4, 8, 16, 30, 50, and the 100 sieve, stacking them in decreasing order by size to the pan on the bottom. The sieves being used are also needed to help attain the finest modulus of fine aggregate. It should be noted that for our test, this material has been tested enough to realize a 3/8 sieve wasn't needed due to the fact no material would be retained on the sieve. Therefore, it wasn't used. Once the sample has been reduced to the proper size and properly dried, it can be poured onto the top sieve. Secure the lid and place a stack of sieves into the shaker. A good rule of thumb for the cycle time is to figure 1 minute for each sieve in the stack, including the pan. After the shaker has completed its cycle, remove the sieves and weigh the material retained in each sieve, recording the weights. Start from the top sieve and work your way down to the pan. ASTM C140-06 Standard Test Methods for Sampling and Testing Concrete Masonry Units and Related Units. Supply is needed: weigh scale, steel scale with divisions of not greater than 1/10 inch, caliper rule having divisional rule not greater than 1/100th of an inch. When receiving concrete masonry units for testing, you'll need 6 units for testing for each lot of 10,000 units. 3 units will be used for compression testing and 3 will be used for absorption testing. Separate the blocks in lots of 3 with the blocks closest in weight and label them for identification purposes. Weighing and measurement. Upon receiving the CMU, Data must be collected for each individual block, received weight, and measurements. When measuring units, all blocks for both compression and absorption must be measured on all sides for height, length, and width. This means 2 measurements of the width taken at mid-length, 2 measurements of height at mid-length, and 2 measurements of length taken at mid-height. In addition to recording the information listed above, further measurements are needed for compression testing. Face shell thicknesses needed to be taken on the top side of the 2 opposite corners, as well as the web thicknesses taken at each of the webs on the top sides of the units. At this time, the units must be stored unstacked and separated by at least a ½ inch on all sides. The air temperature must be 75 degrees plus or minus 15 degrees Fahrenheit and a relative humidity of less than 80% for not less than 48 hours.
My name's Colin Bailey. When I graduated high school, I went to Indiana University as a music major. And I spent 4 years there doing my thing. And when it was time to leave, I had a real hard time finding a job. So I kind of started thinking what else I might want to do. And strangely enough, I've been doing concrete every summer for the 4 years I was at school, and I've been paying all my bills. And I'd heard about a couple schools, and Alpena was always the one on top of the list here for the WCCT. Visited the campus, I was thoroughly impressed, and here I am 2 years later with the degree hopefully in hand, fingers crossed. It's been a really exciting time. I've learned so much. I've been able to really get into all the technical details that I needed to learn to better myself. When I was working before I came to school here, I was kind of a QC tech assistant. I was breaking cylinders in the lab, running slump tests out in the field, doing air tests, everything like that. And I really just wanted to do better. I knew I could. I knew I could kind of get up through the company a little higher if I had more education. So that's why I decided to come out this way. They've really given me the skills here to deal with problems that I've seen in the field along those lines. I was lucky enough to actually receive a job from the company that I've been working for the past 5 years. I started with them in Buffalo, where I'm from, in New York. Then this last summer, unfortunately there wasn't enough jobs there due to the economy, but they helped me find a position in Maryland, where I was working for part of their regional lab and also for the Maryland area as well. And after talking with them this year, I ended up in a manager and training program where they're going to hopefully get me into a decent job, running some big equipment with some fun people, fixing some problems. This school really gave me an opportunity to learn the technical things I needed to learn to fix problems out in the field, to deal with day-to-day issues, just hands-on experience I just could not get anywhere else. I came with an education, or with experience at least, in the concrete industry, in the concrete world, and I am so much farther ahead. I mean, it would have taken me 10 or 15 years out in the real world to try to get what they've packed in here in these 2 years. It's unbelievable from start to finish. You learn everything from the bits and pieces that go into it, to mixing the concrete, to fixing the concrete, and designing it from scratch. It's just great. The instructors here are great. I came from a big university, I came from a big high school, big town, big everything. And to come here to a smaller school, to a smaller town, my instructors actually know my name. I can see them in the hall. They'll ask me how stuff is going. They know what I have problems with. They can help me with hands-on stuff. They seem to know everything. At least that's what they make me believe. But it's great. I have questions for them, and they'll either help me figure it out, or they'll kind of like prod me in the right direction. Just have to figure it out myself and learn a little bit. I mean, they're never afraid that. I'm never afraid to ask a question here, and they're never afraid to answer them. I think that's about me. It's just a great program. I've had a great time here. I've learned so much, and I would not be this well off in life if I didn't come here. That's for sure.
As a graduate of the concrete technology program, I've always been a huge supporter of the program because it has been so beneficial to my career. And as I get the chance to travel the country for Besser Company, I still like to promote the program to high school students especially, and explain to them the importance of concrete, in that nobody yet has figured out a better way to start any construction project than with concrete. So there will always be jobs for concrete technology graduates. And that's one of the nice things about our program. Some of the attributes that I see in our graduating students today are the fact that they have a much better computer knowledge than I ever did as I went through the program. Computers were just coming on the scene at that time, and so I had to kind of learn as I go, whereas today's concrete tech graduates come out of high school with a very good computer knowledge, and they can just move forward from there. The thing I find most intriguing about the concrete masonry industry is the design flexibility with masonry. As architects continue to come up with new and different designs for buildings, the masonry industry has to follow suit and create new molds, new shapes to produce these blocks. Besser Company has been manufacturing concrete block making equipment since 1904 and is the world's leading manufacturer of that equipment. The trend in the masonry industry has gotten away from the old gray block market to one of hardscape and landscape products, meaning retaining wall, patio stones, and the like. In my 20 years in the concrete masonry industry, I still find that the one essential component of the concrete technology program is its hands-on aspect. In other words, what the student learns here in their hands-on laboratory sessions applies to everything that they will do as they continue their careers in the concrete field. The program here utilizes that hands-on aspect to create students that become the liaison between the contractor on a concrete job site and the engineer or architect that designed that structure. And our students that graduate from this program can speak both languages and again become that liaison between those two. As I get the opportunity to work with potential students for the concrete technology program, I'm quite often asked the question of what did I think of my career choice, and did I enjoy my time in the concrete industry? And my answer is always a resounding yes, because I got the opportunity to use the concrete troubleshooting skills that I learned through the program. I get to use some of the math skills, and also got to use a lot of the mechanical skills that I had picked up prior to getting into the concrete industry. I'm always envious of high school students that come out of the program and know, or come out of high school and know exactly what they want to do, because I didn't when I graduated from high school. And I didn't know what I wanted to do, and so I just odd jobbed it for a while, and finally learned that I had to pick a career, and so I entered into the concrete technology program, and even after the first semester still had some hesitation, but continued on and have been very happy with my choice, and have had a very good career, good successful career, and always encourage other students to give it a try and at least give it that first year and see what they can make of it.
My name is David Frary. I'm originally from the Alpena area, and I heard about this program, of course, many years ago. I had friends that went through it out of high school. But I got to the point in '05 that what I was doing I was kind of tired of and wanted to do something different. So I signed up for the program the first time and wasn't able to come. I got an application approval and everything else. We weren't able to work it out. Ended up moving to Texas, where my wife's family lives, and did several different odd jobs while I was there. Couldn't find anything stable, And so I started the program in the fall of '07, moved the family up here from Texas, lived with family for a while, and then we got an apartment in town, or a house, and have been here for the 2 years. Between first year and second year of program, you have to do a co-op, and I was able to get one out at Lafarge, working in the lab out there, in the cement lab, and that's what I've been doing for the last year, working there, and really enjoy it. For project, we have a project lab that you have to do in your second year of the school, and my project lab included concrete countertops, and they needed one in the lab for one sink that was just kind of out there in the middle of nowhere and on a wall. And so I built the cabinet for it and the countertop for it, and learned a lot about concrete in the process, things you should do, things you shouldn't do, and with the possibility of a career, in that field down the road.
So my name's Tanya.
And I'm Shane.
And we're from Montana. Came here to attend the concrete program here at WCCT in Alpena, Michigan. About 1,700 miles from home.
Well, from my perspective, I was dropped out of school basically 9th grade right before I was 16, and kind of working hard last 10 years and having kids and kind of living from that paycheck to paycheck, and already kind of sticking with my jobs though for a year or two at a time, and knowing what I do in my job and saying, well, I don't want to do this, I don't want to do that. Then looking at the concrete technology and the degrees and the scholarships that will help you attain your degree basically for a minimal, just your time and a little bit of experience that you're going to gain. It's the outcome, it's a job security. It's saying you're going to have this type of work for the next 50 years of your life. So now you can retire, you can look at the benefits, your health, think about that now instead of when you're 50, 55, 60 saying, okay, my heart's not good, my cholesterol's high.
And I have no retirement account. Yeah.
So it's more comforting on the person knowing that they'll have something in the future to return to. Knowing that at least you could go with a company, you can stick with it, you have a degree, you can be their security for that company. You could be there for 25, 30 years, then retire with a great retirement.
Yeah.
And being in the concrete industry, it opens up the doors to about 7 or 8 big industries, as in if it's rebar, it's concrete, sales, admixtures, or it's selling just the tools. So there's plenty to do that's in concrete related, so it opens up the door to 5 or 6, 7 different options that you have to pick and choose from. That's all of the world is basically those 7 things if you can't sell it or use it or market it. So we have options in the concrete industry. It's great because maybe you didn't know you wanted to do concrete. Well, you're still going to do a little bit of concrete, but say you're just going to sell it. Well, that's where you fall in, and it's great.
I'm TJ Hammermeister from Virginia Beach, Virginia. They had, down there I was a contractor specializing in concrete finishing. We messed around with a lot of carpentry, masonry a little bit. So we were down there looking, trying to figure out what the next step was, and I stumbled across Alpena Community College's website, and really it kind of saved me. I didn't have nowhere else. I didn't have a next step. I needed more education. I knew there was one thing for sure, that I didn't want to be out there digging trenches for the rest of my life, and that was about where I was going to be if I couldn't figure out a way to get back into school. And what this program has done for me, it's something, concrete's always been my passion. It's always been my hobby. Like, my family's been doing it for 3rd generation concrete worker, but none of us have really went to school for it. It's always just been, passed down from, father to son or whatever. So we needed somebody to go out and actually learn what concrete really does, how it reacts, really the textbook side of the concrete. All of us knew how to work with it, but when problems arose in the field, the only thing we knew how to do is add water to it, or pretty much everything that we learned not to do in this program. And so this program has taught me how to not only excel in the industry that I grew up in, with using different concrete admixtures, how to properly talk to a ready mix producer to make sure that you're getting the proper concrete for the job that you're doing. But also this program has prepared me for many industries. Now I can go out, I can work into engineering fields, I can go and work in an engineering firm, I can go and work in a block plant. There's students that are leaving here, he's running a block plant out in Wisconsin now. One is, he's a plant manager for a ready mix facility. And the limits are endless coming out of here. You can do anything. There's a lot of students, me including, I'm going on to get more schooling. And I would have never done that if I wouldn't have came to this program first. This was kind of, I'm a hands-on individual. I've got to see what I'm doing. I'm not built out for a 4-year school. I've got to have short-term goals along with a long-term goal. And this program right here, it gives that to you. Every day you're constantly, receiving the fruits of your labor. You're out there, you're getting dirty, you're playing with the concrete, you're getting both of the technical learning in the classroom, and then you're applying it into in our labs. So you never feel that your learning is getting wasted. You're never going to lose it because you experience it on both ends and it's drilled into your head. And I know one of the big things that employers look for is hands-on applications. And when we can come out here saying we have an internship between our first and second year, we are hands-on school, we do this stuff for 2 years, we're really unmatched in the industry. And the more the employers see what we're really capable of, the more we're really going to be worth out there in industry. And now, I know with this degree, it's kind of made me realize that I don't just have to be a hard worker. You can use your brain the same as you can use your back. So now I'm going on to pursue a drafting degree. My ultimate goal is, I came in here as owning a company with my father. I plan on going out of here and plan on getting my drafting degree. Then when the economy turns around, starting up another business. Now we've got all the business side of the concrete of the, owning a business. We're gonna have the drafting. We're gonna have everything we need to not only place the concrete, but we can maybe be able to design our own houses. And so that's something, it's one extra year of school out of here, and it's everything that I've wanted to do. I would have never been able to do it if I would have never found this. There's no reason why not to give it a shot. It's 2 years, you'll never regret it. And for me, it was the best education for me and for the person I was coming into the program, the person I wanted to be coming out of it. There was no better fit for a program for me.